Hello, my name is Maria del Pilar Soto, and today CalmCosmetics is proud to present Calmnabbis. This is the CalmCosmetics team. We start with our CEO, Brian Martinez, our CFO, Fernando Martin, DR, Claudia Velez, and I, Maria del Pilar, the QA. To tell you a little bit about our company, here at CalmCosmetics, the vision is to provide our customers with the highest grade of quality ingredients without the need of buying multiple products. Because at CalmCosmetics, we believe people deserve to get the care their skin deserves. That is our mission. Our objectives with today's presentation is to produce an innovative lotion using highly efficient ingredients, introduce how these active ingredients holistically deal with various skin concerns, reveal the secret ingredients of the newest CalmCosmetics solution, and finally, display our process product and process design, including an economical, ethical, safety, and environmental analysis. As a preamble to our product, CalmCosmetics is committed to delivering a dual-action nutri-cosmetic that targets healthy solutions while enhancing every customer's natural beauty from within to without. We guarantee efficiency and an eco-friendly process.
Our nutri-cosmetic comes in the form of a lotion called Calmnabbis, a synergistic combination of three simple but powerful active compounds: CBD, niacinamide, and hyaluronic acid, within a fragrance-free formula. Our ingredients were carefully selected to deliver the finest properties. Niacinamide is well known to minimize redness and pore appearance, provide UV protection, treat hyperpigmentation, block moisture in skin, and build up keratin. Hyaluronic acid is very acclaimed in the skincare market due to its intense and weightless hydration that improves skin texture, prevents oil overproduction, and avoids breakouts. As to CBD acts as our protagonist, being great for all types of skin and rich in vitamins, whose potent physiological and therapeutic benefits are pain relieving, stress reducing, anti-inflammatory, and antioxidants. Also, CBD treats multiple skin conditions such as eczema, psoriasis, and acne.
So, a critical part to actually producing this product is the manufacturing process that it goes through, from being a, a raw material going all the way to becoming the cream that the customer is going to use. It starts with two solutions. One is with oil and another with alcohol solution. Both are mixed separately and they are heated from 25 degrees Celsius all the way to 70 degrees Celsius. After they are heated and mixed, they pass onto another mixer that mixes these both solutions together, and then it cools the solutions from 70 degrees Celsius all the way back to 25 degrees Celsius. After that, it passes to a mixer that adds the preservative for the product. Usually other companies add colors or odors, but our company have decided that we want those that have a sensitive skin to be able to enjoy from our product. So we only add the preservative that is natural and doesn't have any effect on the skin. After that, it passes to a colloidal mill. This mill will will mix those solids in the solution with the solution itself. And after that, we'll have the result of our product, the cream that we desire as a product. So the mixture components. In part A, like I mentioned before, this is the oil solution. This solution is made of stearic acid, cetyl alcohol, petroleum USP, CBD oil, hyaluronic acid, glycerin, monosterate, and niacinamide. And to the right is the mass fraction of each component. As you can see, for stearic acid, the mass fraction is 0.255. And this can be understood as that in part A, which is the oil solution, it has a 25.5% stearic acid. For part B, we have the aqueous solution that is made of deionized water, glycerol, and sometimes gum. And same with the mass fractions to the right. And finally, part C, the preservative that is potassium sorbate. In this case, the mass fraction is 1 because everything that enters through there is potassium sorbate. So it's 100% potassium sorbate. Here we have a table with the results of the material balances, and it has the flow rates of each component and on the different entries and flows. Something to see here is that, like we mentioned before, what enters is what comes out, and as a raw material comes out as part of the product. So, if you can see in stearic acid in the flow 1, there's a flow rate of 6.375, and on flow 7 is 6.364. So, what comes in comes out. It means that in the system we don't have any reaction, any evaporation, no purge, and among others. We don't have any of that. It's just what enters is what comes out as part of the product. And there's a small difference between these numbers, and that's because when the mass fractions have been calculated, they are changed into percents. And when they've been changed to percents, they are being rounded up a little, so it changes the values and the results by just a little. For material balance, first off, we start with the global balance, and we calculate F4 by multiplying F5 by the mass fraction of the preservative. So we multiply those, and we have as a result the flow rate of F4. For F3, we subtract F4 from F5, and we have the result of F3. And for F1 and F2, we do the same process as we did for F4. We multiply the flow rate of F5 times the mass fraction of those solutions, the oil solution and the mass fraction of the aquatic solution in the final product. Then we calculate the mass flows. These are the mass flow rates of each component. So we multiply the flow rate F1 by the mass fraction of that specific component. So for F1, we multiply F1 times the mass fraction of stearic acid, and so the same thing we do with CBD and with water and with all other of the components that we have. Then we calculate the F3 mass fraction. For the mass fractions, we solve for the fraction by dividing the mass flow rate of that specific component divided by the flow rate of F3. So in this case, we divide the flow rate of stearic acid by the flow rate of F3, that's 199.5, and that gives us as a result the mass fraction of that component, and so on for all of the other components. Same thing goes in F5. For the mass fractions of each component in F5, we divide the the mass flow rate of that component, specific component, in F3 or F4, and we divide it by the flow rate of F5, and that will give us as a result the mass fraction of that specific component in F5. And finally, the mass flow rates in F5 of each component is multiplying F5, the flow rate F5, multiplied by the mass fraction of that specific component. And that's how we calculate it for every single component. Here we have the energy balance results. We have two columns which have the heat values and two columns with the flow rates of each entry and exit. So here is how we calculated each heat. So since we don't have kinetic energy nor potential energy, nor we have work in the system, the change in enthalpy will be equal to heat. So we calculate the change in enthalpy, and as a result, we'll have heat. How do we do that? We multiply the molar flow rate of each specific component by the integral of the heat capacity of that specific component. 25 to 70 degrees Celsius and from 7 degrees Celsius to 25 degrees Celsius, depending on where it's done. If we pay close attention to part B, the molar flow rate is calculated by multiplying the flow rate of that component and change it. Since we have it in kilograms by hour, we change it from kilograms to grams, and then we multiply it by the molar mass of that specific component. And grams cancel grams, so we are left with moles divided by hour and multiplied by the integral, which the integral results in the heat capacity of that component multiplied by by the the last temperature minus the initial temperature, and we multiply all, and then we change units all the way to kilowatts. And if you pay close attention, part B and part C have the same amount of heat. The thing that changes is that negative. Why is this? It's because in the first one, in part B, it goes up from 25 degrees Celsius to the temperature of 70 degrees Celsius. So in order to go up in temperature, it absorbs heat. Meanwhile, in part C, it lowers its temperature, apologize, from 70 degrees Celsius to 25 degrees Celsius. So the solution is letting go and liberating heat. Then that's why it's negative on part C.
Our company's work environment, business practices, and ethical decisions are premised on a value-based culture that promotes respect, integrity, accountability, quality, and growth, among other core values. Now, reviewing our ethical considerations, our team operates strictly following the Code of Ethics provided by the Global Fund of Chemical Engineers and the National Society of Professional Engineers. We ensure transparency and honesty to corporate government and investors by fully disclosing all material facts affecting our company and its position in the market. Environmental performance standards are recommended by the Environmental Protection Agency, EPA. As well, animal welfare is assured with vegan ingredients and cruelty-free testing. Safety considerations are an integral part of our company. Following the Health and Safety Authority policies, CalmCosmetics guarantees the design, provision, and maintenance of a safe workplace for all our employees. Guarantees the performance of ongoing hazard identifications and risk assessments. Guarantees the dissemination of safety information, instruction, and supervision, the provision of welfare facilities, emergency plans, personal protective equipment, and first aid services. As to health analysis, 99% of our ingredients, including mixture compounds, are identified as non-health hazards and are approved by the FDA for external use only. Regarding our main ingredients, hyaluronic acid is a substance naturally present in the human body, and CBD is an organic substance extracted from the hemp plant. Safety data sheets define niacinamide as a non-irritant and a preventable health risk that does not include skin irritation.
On the environmental part, we prevent releases to soils and water bodies, and we also employ incinerators to deal with waste and prevent air pollution. Also, the major part of the ingredients of our products are biodegradable, and we use eco-friendly materials for packaging. In the financial aspect, we spend $170 per hour in workforce, and our equipment is valued in $19,000. In the right side, we leave a list of the prices in dollars per kilograms of our processed materials. For every 2,000 for every 200 kilograms of product that we sell, we earn a net income of $33,000 approximately. In conclusion, we're offering a product that has multiple benefits for the consumer skin, that is secure, eco-friendly, and economically viable. The fulfillment of this project would not have been possible without the expertise of Dr. David Suleiman, to whom Calm Cosmetics is pleased to extend our special recognition for his contributions and detailed guidance. Here are the references, and we want to say thank you to the public. And if you have any questions, you could make it now.